Hi, in this video, we are going to see how to solve quadratic inequalities. Okay, let us consider a quadratic inequality x square positive 5x positive 6 greater than 0. So the first step is we have to factor this quadratic expression. Here, the constant term is positive 6 and now we have to get factors, two factors for this constant of positive 6 so that the product of the two factors is equal to positive 6 and the sum is equal to the middle term positive 5. So positive 2 and positive 3 will work. So when you multiply positive 2 and positive 3, that is equal to positive 6. When you add positive 2 and positive 3, that is equal to positive 5. Okay, so the two factors of this quadratic expression are x positive 2 and x positive 3. Okay, now you have to assume this inequality as an equation and solve for x. Okay, I'm going to do this one separately. So now I'm going to assume this inequality as an equation. That is x positive 2 times x positive 3 is equal to 0. So the product of these two factors is equal to 0. So either the first factor x positive 2 must be 0 or the x positive 3 must be 0 so that the product can be equal to 0. If x positive 2 is equal to 0, then we get x is equal to negative 2. If x positive 3 is equal to 0, then we get x is equal to negative 3. Okay, now we have to mark these two values, negative 2 and negative 3, on a number line. So here the left side extreme value is negative infinity, the right side extreme value is positive infinity. And we'll have negative 3 and negative 2. And we get three intervals. The first interval is negative infinity, comma negative 3. And the second interval is negative 3, comma negative 2. And the third interval is negative 2, comma positive infinity. Okay, now we can take a random value in the first interval, negative infinity, comma negative 3. So a random value can be negative 4 or negative 5, anything. So which is less than negative 3. So negative 4 we can consider. If you plug in x is equal to negative 4 into this inequality, what's happening? If x is equal to negative 4, the value of this factor, this negative 4, positive 2 will become negative 2. And if I plug in negative 4 for this x, negative 4 positive 3 will become negative 1 greater than 0. Negative 2 times negative 1 will be positive 2 greater than 0. Now, my question is, this is true or false? Yes, it is true because 2 is greater than 0 is true. So, the first interval, negative infinity, comma negative 3, satisfies the given inequality. So, this can be accepted. Now, we have to test the second interval, which is negative 3, comma negative 2. Now, you can take a random value in the second interval as we have done in the first one. So, the random value in the second interval, that is, you can consider any value between negative 3 and negative 2. So, we can consider negative 2.5. When I plug in x is equal to negative 2.5 into the first one, it will be negative 0.5. And when I plug in x is equal to negative 2.5 into the second factor, it will be positive 0.5. When I multiply these two values, I'll be getting a negative value. Yeah, negative value greater than 0 cannot be accepted, it's false. So the second interval, negative 3, comma negative 2, does not satisfy the given inequality. So the second interval cannot be considered as a solution for the given quadratic inequality. Okay, now let's test the third interval, which is negative 2, comma positive infinity. You can consider any random value in the third interval. So we can consider 0. So if I plug in x is equal to 0 into the first factor, it will be 2. And into the second factor, it will be 3. 2 times 3 is 6. 6 greater than 0. This is true. So the third interval satisfies the given quadratic inequality. So the two intervals, negative infinity, comma negative 3 and negative 2, comma positive infinity. These two intervals satisfy the given quadratic inequality. So the solution for the given quadratic inequality can be negative infinity, comma negative 3 union negative 2, comma positive infinity. Or we can write the same as negative infinity, comma negative 3 or negative 2, comma positive infinity. Okay, now let's look at another example. Okay, now we can consider the inequality x square, I mean quadratic inequality x square negative 11x positive 24 less than or equal to 0. So here also we have to do the same thing. That is, we have to factor this quadratic expression. Here the constant term is positive 24. Now we have to get two factors for this positive 24. That is positive 3, I'm sorry, negative 3, negative 8. So the multiplication of these two factors is equal to positive 24. When you add negative 3 and negative 8, that is equal to negative 11. So the two factors of this expression is going to be x negative 3, x negative 8 less than or equal to 0. So now you can assume this inequality as an equation and solve for x. So if I assume this one as an equation, I'll be getting x negative 3 times x negative 8 equals to 0. Then x is equal to 3 or x is equal to 8. Now we have to mark these two values on the number line. We have to split up the whole real number line into intervals. So we have negative infinity, positive infinity, 3, 8. So the first interval is negative infinity, 3. Here we can use the closed interval, that is square bracket, because we have less than or equal to. So 3 and 8 both can be considered as a values of x, because even when you plug in x is equal to 3, so the value of this expression will be 0. 0 is equal to 0 can be accepted. And the second interval is 3, 8. And the third interval is 8, positive infinity. Okay, now let's take a random value, the first interval, negative infinity, 3. So obviously it's 0. So if you take 0, for x, it will be easier for us to check whether value 0 satisfies this inequality or not. When you plug in x is equal to 0, this one will become negative 3 and this one will become negative 8. Negative 3 times negative 8 is positive 24, less than or equal to 0, it's false. So because any positive value can never be less than or equal to 0. So the first inequality does not satisfy, the first interval, negative infinity, positive 3, does not satisfy the given inequality. Okay, now let's take a random value in the second interval, 3, 8. So it can be 4. If I take x is equal to 4, the value of this factor will be 1 and the value of this factor will be negative 4. 1 times negative 4 will be a negative value. Negative value less than or equal to 0 is true. So the second interval satisfies the given inequality. Now let's take a random value in the third interval, 8, positive infinity. It's just 9. Then in that case, its value will be 6. It's a positive value. And 9 minus 8, this is also positive value. The product of two positive values is always positive. So which can never be less than 0. So that's false. So the third interval does not satisfy the given inequality. So the solution for the given quadratic inequality is 3, 8. Here, please remember both 3 and 8 can be included. The reason is we have less than or equal to 0. When you plug in x is equal to 3, it will become 0. 0 times anything, it's 0. 0 less than or equal to 0, it's true. Because 0 can be less than or equal to 0, 0 is equal to 0. And also when you plug in x is equal to 8, this factor will become 0. 0 times this factor will become 0. So in this case, both the end values of the interval can be included.